Welcome, everybody. This is day 2 of the BigBlueButton World Summit. It's my pleasure to introduce Samuel Reach, who has been with us as a project for many years. He is a university lecturer for data protection and data security in medicine at the, Samuel, can you just pronounce the university?
Technische Hochschule Mittelhessen.
Thank you. University of Applied Sciences. He also manages the BigBlueButton infrastructure for the Faculty of Health Sciences and leads the development of PILOS, which is an open source, kind of really nice, complete front end for BigBlueButton, which I think we may be seeing a little bit about here. Samuel, over to you.
Thank you very much, Fred. So yeah, today I want to talk about something new. So in the last different BigBlueButton World Summits, I talked about PILOS a lot, kind of the alternative front end that we developed here at the Technische Hochschule Mittelhessen. But today I want to talk about something else, a new product that we just launched a few weeks ago, and it's called the BigBlueButton Streaming Server. So to start with this, we should have a look at the motivation. What is the background? Why did we start this new project? And to talk about this, we need the background, and the background is that a customer from a different state here in Germany contacted us, and they wanted to use PILOS together with BigBlueButton for their special use case, but there was one key element missing for them, and that's why they contacted us. And that key part was live streaming to a video platform. So what was the requirement of this customer that we wanted to deal with? And the requirement was that there should be a BigBlueButton session for a public parliament chamber where the different people inside of this parliament could debate together. And then for some topics that would be interesting for the public, everyone kind of in this state should be able to watch the public debate, like in a parliament that's broadcasted via TV and everyone can watch it at home. So bringing BigBlueButton to public parliaments was kind of their main goal. But they didn't want the public to be inside of the BigBlueButton session. So the requirement to achieve this has been that moderators or the person who's responsible for this BigBlueButton session should be able to start and stop a live stream, but also be able to pause the live stream in between for sections of the debate that should not be public or for different pauses. And it should be able for them to do it on their own, so no need for special technical personnel in that area. Where did they want to live stream this to? Should this be a separate platform that's developed? No, it should just be live streamed to existing video platforms using RTMP. And in the end, this whole solution should be self-hostable in their own data center, and it should be open source and brought back to the community. If we have these requirements, it makes sense to first look at other projects that are out there. Because if you Google for BigBlueButton and livestream, there are a lot of projects that come up. So let's first review them. What do they offer? And is this a solution for our problem here? So there are 3 big open source products that are out there that claim to solve this issue. So first there's a project called BBB Streaming. This has a few contributors. Their last commit has been 2 years ago, and they have a Docker container that you can start. You enter the server credentials and the meeting details, as well as the RTMP credentials, and then on the console or the server, you can then start this container. Then it's starting the live stream, and as soon as the meeting is over, or you stop the container, then the live stream is ended. So kind of that's one project. Then there's a different one. It wasn't updated a bit longer. 3 years ago was the last commit. It's also Docker-based, and you have a few more options. So you can configure what should be visible in the live stream. So there are environmental variables to do this. And what's kind of unique for this project is they have a back channel. So users can enter chat messages on a website, and then it's sent back to the container, and then that one is inserting it into the public chat as a message. And the third one is also an open source project, last updated 2 years ago. It also has a Docker container, and one of their unique features is that they have a script that's modifying the BigBlueButton client on the fly and inserting something that we today call a plugin, but it was done before the plugin architecture. So it's modifying the HTML client. It has a REST API, and it should be able to support concurrent streaming. Looking at the GitHub issues, it doesn't look like it's working with 2.7 and also not with 3.0 anymore. In the open source area, there's also another project, and it's called Sprout Breeze. It is one of the BigBlueButton supporting companies. They wanted to launch this about 4 years ago. It's a very complex system. It's not really meant to be an odd add-on for BigBlueButton itself, kind of as a plugin, but instead it should be a webinar platform. That's their main goal. I talked to Tazi, who's the maintainer of this project, a few days ago. What the status of this project is, it's not stopped, it's just on hold until they find enough financing support to continue developing this. But it has kind of a different use case. It wants to build a webinar platform. And if we look into software as a service products that are not open source, there are also 2 products out there, one called BBB Room Live, and there's a German BigBlueButton hosting company that has their own BigBlueButton management front end, and inside of that you can also enter RTMP credentials, start, stop the live stream, and you can also pause it, uploading a pause image. And when I joined this session a bit earlier today, I also saw that mconf has a BigBlueButton plugin. That's really awesome, where you can directly manage the stream inside of BigBlueButton. That's really awesome. But sadly, it didn't exist, at least to my knowledge, when we started. And as far as I can tell, it's not open source, at least to my research this afternoon. So if we go back now to the requirements of the customer and compare this with the products I just talked about, and if we check this, then we can see that the requirement that moderators should be able to start and pause the live streams themselves without the need for technical personnel, that doesn't work with kind of the open source project that we saw, because the first 2 require users to start a container on the console. That's not possible for someone who doesn't have this technical expertise. Also, they would need to have the BigBlueButton credentials and then have access to the whole server. That would be a no-go in this area. And the third one would require a modification of the BigBlueButton core, and we didn't want this because then we cannot upgrade. Also for security fixes, that's not an ideal solution. So none of these open source projects really solve these customer requirements. The projects that were hosted that are not open source, they would fit kind of this requirement, but it wouldn't work if they want to self-host it and they want to have it open source so they can look into the source code. So given kind of that there's no solution that's really fitting the needs of the customer, we started developing and thinking about how can we do this. The existing projects that existed on GitHub, the open source projects to live stream, are a very good starting foundation that we wanted to build on. So instead of reinventing everything from scratch, we wanted to build upon these open source products. In the end, we had to change a lot, but at least that was our idea in the first place. Then the second thing was we wanted to add pausing to the live stream, also kind of with the picture that's shown in between, so the viewers know that it's paused and it's not a system failure that's currently happening. And the idea behind this was we thought maybe there is a command or anything like this for FFmpeg that's kind of used in all these projects to stream, where we could dynamically switch the inputs between the BigBlueButton session and a static file like a pause image. And if there isn't this command, if this doesn't work, then we hope that there's maybe another open source project out there that would allow us to do this thing. And the second one was that we needed to have a system that's scalable, so multiple sessions can happen at the same time, and we wanted to kind of have a system in place that might be able to automatically then start these Docker containers so the user doesn't have to do it themselves. And to integrate this into other systems, we needed to have an API with what we can then control this, start the meetings, monitor them, and we didn't know where we want to place this, either on the BigBlueButton server itself, kind of as an extension to the BigBlueButton API, or on a separate server. So let's dive in. What were the challenges involved into this product? So the first one that we figured out that there's sadly no command in FFmpeg to do this dynamic input switching. That's not how the software is designed. It has one input and one output, and there's no way to change it during the runtime. That's very sad, because that was kind of our main hope, that we could solve it that way. So the second approach was that we have two separate FFmpeg processes. One would be capturing the content of the BigBlueButton meeting, and the second one would have the pause image. And as FFmpeg supports kind of piping commands, we could send the output from the first FFmpeg to a custom component that we would call the worker, and then forward this data to a third FFmpeg process that would then send the data to YouTube. And this middle component would dynamically switch the pipe and discard all the content of the pipe that is not needed at the moment, and forward everything into the second pipe to FFmpeg that's currently interesting. That was the idea. Reality hit us hard at that point, because first of all, it's really utilizing the system a lot, running 3 FFmpeg processes for each BigBlueButton session. And the second main issue is that kind of the different packets that are sent, the FFmpeg TS files, you cannot just simply cut them at a random point in time and expect it to work. FFmpeg can correct the packets if they are corrupt due to kind of cutting it in the data flow, but it's not really working well out, because the packet numbers need to be continuous and you have audio cracks and video glitches. It's not really a system that we felt comfortable with continue working, even though we spend a lot of time trying out if we can make this solution working. We also researched during kind of this nightmare if there's any other open source product out there that would be easy to integrate and solve this, but sadly there was none, at least to our research. So that was kind of one of the main issues. We will come to the solution, how we ended up doing it in a second. Just wait a moment for this. The next one was, how can we do this scaling stuff? So how can we support multiple simultaneous live streams? So there were 3 different approaches that we wanted to look in to. The first idea would be, we have a controller system that's running on the system, like a BigBlueButton service, that would then access the Docker daemon on the host, and it would start Docker containers on demand, and each Docker container would isolated stream kind of the live stream, and you could launch multiple ones. That controller could monitor this and kind of restart them if this is needed. From a security perspective, we didn't really like this approach, because this container, if there are any vulnerabilities in there, it would also affect the host, and you would have to deal with the complexity of the installation. It's not as easy as installing a Docker container. You would have to need all kind of the different requirements on the system, update packages, and so on. The second approach would be to run this controller also in a Docker container. That would kind of solve this security issue, but it would open up a second one, because you cannot launch a container within a container. And instead, you would have to expose the Docker daemon to the container itself. A few products do this, like Traffic, but it's not really recommended. It's an anti-practice from a security perspective. So we didn't want to really do this if this is not absolutely necessary. And also giving kind of this whole container control to the controller would add a lot of complexity there. So how do we do it in the end? We came up with a third strategy that's completely isolating this container orchestration by having multiple work containers running at the same time and giving the orchestration back to the tools that are good at this, like Kubernetes or Docker Compose. And these containers are not tightly coupled, but instead loosely coupled using a message queue, how the containers can send commands to the worker, and then inside the worker, we can then stream the data. The last question that we had to solve was, where do we place this whole system? Should this be on each BigBlueButton server? If we would do this, then it would be easy to scale, because the more BigBlueButton servers you have, the more systems to live stream you also have, and then you can horizontally scale this. But there's one problem with this approach. If we would do this, then each BigBlueButton server would get a new route to control the live streaming. And as a consequence, every BigBlueButton server that's running behind a load balancer, the load balancer would then also need to support this new API. And that would require changes in all the different load balancer projects. And that was not really a solution that we felt would work in the long term, because it's not very likely that all other open source products out there that do load balancing would kind of add this complexity to their product. So instead, we wanted to make a separate server, a custom API to control this, so we don't depend on the load balancer to handle kind of new API endpoints. So how does the architecture look like in the end? How did we achieve this? So we have three main components involved in there. First one is the controller container. Second one would be the worker container. And then we also have a Redis container running a Redis database. The data flow would be that we have a REST API that is exposed from this controller container. The REST API can accept requests to start, get the status, pause, resume, and a Node.js script would then start this as a job in a message queue system called BullMQ that is kind of a product that's working well with Node.js. And this job is then added to the Redis database, and the worker container can subscribe to this job queue, get one job that should be started, starting their own new process to process this streaming job. So each job is in a separate process, isolated so they don't influence each other. Inside of this live streaming component, that's a separate Node.js product, then we launch two processes at the same time. One is a Puppeteer, and the other one is FFmpeg. The Puppeteer component is started with the join URL that is provided via the REST API once we say we want to start a live stream. And during the processing, we can also send commands over to the Puppeteer container to intercept kind of the live stream, like pausing and resuming the live stream. So that one is then launched in Chrome, and inside Chrome, there's a plugin that's recording the content, sending the data stream back to the main component over here, and that one is sending it to FFmpeg, which is sending it to the endpoint where we want to see the live stream. So how do we do the pausing? It's a kind of hacky way in a bit, but it works very well. We inject a pause image full screen on the BigBlueButton page that's kind of blocking the content visually, and then we turn off the audio of the live stream so there's no sound transmitted anymore. The FFmpeg component can report that status back to this component up here, which can then send it back to BullMQ and over to the container where our API can access the status. So that's the idea from the technical perspective if we look at the architecture. So what are the features? So it is Docker-based. It is controlled via API only. We can customize the BigBlueButton client fully to our requirements, what should be visible, how it's styled, using all the different parameters that's available in the join URL, because they are just passed from the place where we start the live stream from. We have environmental variables with what we can configure with MPEG. We can support the concurrent streams. We have structured loggings. We have Prometheus metrics, how we can monitor the whole system. We have two different strategies for scaling. One is the worker mode, where we launch multiple containers, and inside each container, we can handle multiple streams at the same
Vamos a
time.
tener estas estrategias.
One, so only one container is handling one live stream at a time, and we can set a fixed number of these workers.
Podemos
you can also build your own scripts
tener un número fijo de
or in terms of the job
containers que están trabajando y lanzar otros.
Is only doing one job, and as soon as it's finished,
en términos de modo de trabajo, tenemos que entender que un contenedor hace un trabajo, otro. Y la idea es cómo implementar.
It's a simple Docker Compose script that you can install within minutes.
Si estás en el modo worker,
you can
es más
start,
fácil.
stop the live stream, and you can pause and resume with a custom image.
Los recursos.
So now the interesting part, let's come to the live stream, the live demo. So how does it look like in action? Is it really that simple?
Una
To
demostración
do
en
this,
vivo
I will
sobre
share
cómo
my
es
screen so you can follow me.
cómo está cuando está en acción, cómo funciona.
So what you can now see is the YouTube studio where we want to receive this live stream.
Pueden acompañar, estamos en YouTube Studio.
I will also post a link so you can follow along in
Vamos a empezar una live en un minuto.
The live stream in a moment. So now we will go to PILOS.
Estoy poniendo el enlace para que puedan acompañar
we developed and where we edit this new
de la mejor manera posible.
That is a room. Inside of that room, there's a new
Tenemos que ver dónde hicimos la edición.
If we click on this streaming
Aquí está la
icon,
configuración que se llama transmisión, streaming en inglés.
We can configure this live stream. If we click on it,
y podemos realizar la configuración de esta transmisión en vivo.
RTMP URL to not expose the real information. I have a second one where kind of this data isn't blurred, so you can enter your credentials in here.
Ver maneras de insertar datos.
What else you have in the admin settings? You could configure for what room types you want to allow streaming or not.
Y otro punto es que podemos configurar otros tipos de transmisión.
There's a default pause image system-wide for each room type, and the user can also upload their own pause image. So we will now upload our custom pause image
Es posible realizar el upload,
so we have
subir
custom,
el contenido.
If we now start this meeting,
salvarlo.
we will get a notification that live streaming might be enabled.
Si empezamos esta reunión,
stream the content, so we have to be
podremos ver
I will just quickly change
que hará una transmisión en vivo del contenido y
if
por
we
lo tanto
now
tenemos que
go
estar
to second
bastante
tab,
atentos.
Back to PILOS, we now
Si vamos
see
a la
the controls here.
segunda
We can
parte,
start, stop, pause, or
de
resume
vuelta
the
al
live stream.
PILOS,
At the
tenemos
moment,
el
because it's
control,
not started, the only thing we
iniciar,
can do is we can
pausar,
start the live stream. Now it's
parar,
queued, so we will
seguir,
wait
resumir.
until the process is picking up this live stream job. Now it's running,
pongo
and
start,
in here we
ya
will
empieza.
see that the live stream is starting,
Y
and
aquí
we can see the image here.
veremos que hay una transmisión
Okay, so
en
there
vivo que
is
ya está
our
empezando y
BigBlueButton
veremos también
session.
la
What can we
imagen.
do? We can draw on the whiteboard,
Podemos
and then it's
diseñar
broadcasted, and we can also
en
share
el cuadro
videos
blanco,
and watch them
también compartir
on
videos
YouTube as well. I will just launch it here, muted,
y verlos por
and
YouTube.
so we can go here over to BigBlueButton, and we can see how the video is played. You can follow along at your own
Ver
browser
en
and kind of listen and watch kind of the quality of this content.
Y acompañarlo a
If we
través
don't
del
want to
navegador y ver la calidad.
continue showing kind of the content, we can pause. And it's pausing the live stream, and if we go here, we can see that live stream has been paused. There's no audio anymore. You cannot hear Fred talking about BigBlueButton 3.0, and then you can resume, and then the live stream is resumed here. There's always a slight delay in the sending the RTMP and the encoding on YouTube. And if you're finished, you can simply stop the live stream, and then it's stopped here. You will get a notification that there's no longer any data transmitted, and then YouTube is stopping the stream, or you can do it yourself. And it's working with all the major platforms that support RTMP. So we'll go back to the presentation and have a short look at the docs in the BigBlueButton, in this BigBlueButton streaming server GitHub repository. You can find OpenAPI documentation how this API works, so you can start implementing it into other products. And that's kind of what the last slide for this talk will be. I highly invite you to contribute to this product. We're really looking forward to users that start implementing auto-scaling. If this is something that you are interested in, there are some ideas how this can be done in the README. If you have a working solution, feel free to submit this and give it back to the community so others can benefit from your own scripts to auto-scale this. And also feel free to add this to other BigBlueButton front ends like Moodle, Greenlight, Nextcloud, or what else is out there. It's really easy to implement, and it's a very nice
como
feature
Moodle, Greenlight,
to
Nextcloud.
And if you're really excited about the new plugin architecture, Orion, and looking forward to the talk about that, I think tomorrow, you can also try adding it as a plugin to BigBlueButton itself. So this can not only be controlled via the front end, but also directly inside of BigBlueButton. And I'm really hoping that this could work out, and especially the new feature, external data resources in BigBlueButton 3.0 might be a very handy solution to achieve this. Thank you very much for your attention, and I look forward to hearing
BigBlueButton 3.0. Bueno,
so Samuel, that was amazing. Very impressed with the research and the thought process and the architecture.
Bueno, estoy bastante impresionado
and I do hope other people contribute towards it.
La arquitectura.
I'd like to promote this in the project as well and get as many people around it, because you certainly have got a lot of good thought that's gone into it. I will actually, the next session is about to start. So Samuel, I will thank you, and I will, gosh, can't wait for next year.
Bueno, la próxima sesión ya va a empezar. Les agradezco. No puedo esperar.